Okay, this is Station 7, Measuring Liquids. First step is to read Measuring Liquids, which is right here. So I'm going to read this. Most commonly used instruments for measuring liquids in the laboratory are graduated cylinders, burettes, and measuring pipettes. Each of these instruments has a scale marked on its side. In most cases, the larger the measuring device, the less precise the scale. Graduated cylinders are designed to measure the volume of liquid they are holding. Thus, the 0 milliliter mark is at the bottom of the scale. You can see that just by looking at the graduated cylinder. 0 is at the bottom. Burettes and pipettes are designed to measure the volume of liquid they deliver. So here is a burette. I don't have any pipettes. So as you can see probably at the top here, the 0 line is right there between my fingers. And then it goes all the way down to 50. So when I open this up and it goes down, it's right now about 27, and then it will go down. So from 27 to 29, that would deliver 2 milliliters. Okay? You don't always have to start at 0, but it makes it a little bit easier. On the scales of these instruments, the 0 milliliter mark is at the top. This permits the user to read the amount of liquid that has been delivered from the 0 mark. In all of these instruments, the surface of the liquid will be slightly curved. This curved surface is called a meniscus. You should know that by now, I hope. The curvature is caused by the combined effects of the pull of gravity on the liquid and the attraction or non-attraction of the liquid for the glass of the instrument. Most liquids are attracted to the glass and are said to wet the glass, quote unquote. The meniscus formed by such a liquid is concave, curved downward, kind of like it's caved in. Such liquids as mercury that do not wet the glass form a convex meniscus. When reading the scale of an instrument containing a liquid, you read to the bottom of a concave meniscus and to the top of a convex meniscus. Figure 10 shows the correct and incorrect lines of sight in reading a concave meniscus. Now, if you look carefully, this says if you're reading too high, the line of sight is too low. So if you're reading from the bottom, your reading is actually going to be too high. So what you come up with is too high. Proper line of sight right here is going to be directly across from the bottom of the meniscus. If your line of sight is too high, it's actually going to come up with a lower number. Your reading is going to be too low. Okay, secondly, it says, compare the graduated cylinder with the burette, pipette, and beaker. Well, I've got a beaker here, and I've got a graduated cylinder, and we already saw the burette. Burette is the most accurate out of those. The narrower the measuring instrument, the more accurate the measurement will be. Of the instruments at this station, which would be the most accurate? I kind of just gave that away. Which would be the least accurate? When you're over here live, I want you to tell me, take a guess, as to what the actual measurement is of the liquid in this beaker. You're going to be surprised, I think. Okay? Well, that does it for Station 7.